here is a new shape. And yeah, we're going to copy these measurements. That's very generous that they gave us some of this action. Well, yeah, we got this shape, right? This is a prism, right? So the last example was a cylinder. This is a prism now. And we know that because it's not a circular base right here. This is a six-sided shape, which is a hexagonal prism right here. And so, yeah, we got, that's why it's showing six. Those should be rectangles, but squares will work, I guess. And then you got the hexagons as the base and the top. I call it the top and bottom, but whatever, okay? So we need to put these measurements on this, on the hexagon. Yeah, it's showing that it's important to know that's a bisector right there. What I really want you to know right now is that creates a 90-degree angle, which is really all we need for that. And I'll show you why here in a second. And that is a 6.9 units. That's a 9 right there. Okay. And then it shows kind of, and again, we get to assume that all these lengths are the same. So it's a regular hexagon. Yeah, I understand it. It is difficult to show a three-dimensional shape in 2 dimensions. But yeah, it is tilted right here to show that it particularly that it's in the center of that hexagon. Going specific, well, again, to the middle of it. The nice thing about this is we know that they're pretty much only going to give us regular shapes. So all of the lengths on the edges of the hexagon are going to be 8. And so the 9 right here is the height of this thing right there. That's the 9. So that means we could label each of these squares, right? These would be 8s right here. And that would wrap around the shape. And so the 9 height would be this one right here. Now you could put 9s all along here if you'd like. Not that you have to. But you'll notice that it creates rectangles that are all the same. It's just 6 of them, right? So if I said, hey, we want to find the area of all the rectangles, what you can do is just find the area of one and multiply it by 6. Or if you wanted to, you could say, I'm going to add all the 8s up. So that's 8 and 6, so that's 48 by 9 rectangle. And then you could find the area that way, okay? I'm going to go with what I said originally. So I'm going to find the area of one of those rectangles, which is a 9 by 8 rectangle. And 9 times 8 is 72. But we have 6 of those rectangles, so I'm going to multiply the 72 by 6. And yes, I do need a calculator for that. If you don't, then more power to you, man. 432 square units on this, okay? So that would be the full area. The 432 would be the full area of just the rectangle part, okay? So we need the area of the hexagon. And by the way, the 432 square units, that's the lateral area. All of those rectangles constitute the lateral area.
Are you doing the surface area?
So to find the surface area, let's kind of zoom in on this and figure out what the crap is going on. 6.9 is good. We know that. In fact, we know that this bottom part here is 8 units. Right? I'm using the wrong color. These are 8 units each, right? 8 and 8 and 8. Okay. Well, what we're going to do is we're going to split up this hexagon into smaller, more manageable shapes. Shapes that we're familiar with, like rectangles and, well, triangles, okay? Well, since they said this is from the center to the edge here, what we're going to do is we're going to make this a triangle right here, okay? And I can find the area of that triangle because I know that the base of that triangle is an 8 right there, okay? And also the height is 6.9. So if I said I want to find the area of that triangle, just the triangle part, I would take the 8, the base, and the height, 6.9. I'm going to multiply those. But we need to cut it in half, right? So I type this into my calculator, 8 times 6.9 divided by 2. And this rounds it for me. Oops. As the area is 27.6 square units. Well then, we just need to ask ourselves, how many of these are there? Well, that would be 1, the one that we found originally. There's 2, there's 3, 4, 5. I know some of you knew the answer before I started there, but 6. 6 of those. Yeah, now you could say there's 12. Now, I was looking at the full big triangle right here. So, it is possible that some of you cut that in half, right? You'd say, hey, look at this. It's half of one. And you could say, you could find the area of that one right there. Yeah, so we do have the other hexagon, but I do want to find just the area of this one for now. So that's 27.6, but yeah, we need to multiply that by 6. So I go back to the calculator, 27.6 times 6 is 165.6. Again, that's square units. But again, there is 2 of these, so multiply that by 2, which gives us 331.2 square units. Now that was a lot of work and it was fun. Or I'm going to say that it was fun. But to find the total surface area, because we do have the lateral area, we need to take the lateral area and add the surface area of those 2 hexagons, which was 331.2. And whatever we get out of this will be the full surface area. Sometimes we'll just say SA. So what is that? A 2 and a 3 and a 6. Whoops. Decimal. 4 plus 3 is 7. 763 square units. That's what I'm going to say. Yeah, same with the 432. That would be in square units as the lateral surface area.